Hello and welcome to VitoshAcademy. Today we will be talking about sine and cosine again, and we'll be talking about sine and cosine a bit more for beginners, and we will be introducing the unit circle. So this is the code with the libraries that we will be using. I have introduced font size, which is something that we are going to use in the unit circle in almost anything. Okay, here we're using font size +2, but it is something. And this is our new friend for this video, the unit circle, your new best friend, as you see here. So what is this unit circle doing and what it has to do with sine and cosine? That's a great question that you probably already have in mind. And the answer is that can imagine a perfect circle with radius 1. So this one to this one is 1, as you see, and additionally in any direction the radius is 1 because this is a radius. This is centered at 0, 0, and you can think about it as a clock face, but instead of hours we measure angles. So every angle theta points to a unique spot in the circle, and the x-coordinate, this one here is the x-coordinate, the red one is the cosinus, and the y-coordinate, this one, the blue one, is the sinus of theta. So think of the theta as a direction like 30 degrees northeast. Cosinus theta tells you how far to walk. As far as this one here should be north. What I'm thinking in order to remember that this is the sinus is I think about the sun. And the sun is always on top, so this one is always the sinus. Let's start exploring some key angles, and I'll start typing a bit here. So, which angles are we going to explore? The answer is, let's see, angles, they will be 0, 90, 180, and 270. And we are going to put some colors in them. So say purple, orange, green, and the fancy way to say blue is cyan. And now we would start figuring this pretty much. Fixed size is 8 by 8. This should be enough. And what do we do? For degree and color in a tuple angles colors. Let's do the following. We're going to put the degrees as in radians. So degree to radians, this is how it works. And then the x and the y would be the cosinus of the radian and the sinus of the radian. Already seeing that cosinus and sinus are going to be really, really useful. What else should we need? Ax scatter, of course. We need the scatter just to put the points. Color is this one, color. And let's see what we would be having. Okay, so we have everything but the circle, but we already see that we have the 90 degrees here up as far as it is orange. This one, we have the purple here at 0, we have the green here at 180, and we have cyan at 270. Okay, so far so good. And after some fixing of the code here, I just managed to make it nicer, where you see the 90 degrees, the 0 degrees, the 180, and the 270. So let's talk about these key angles. So let's take a look at the 0 degrees. Pretty much, what is the 0 degrees? It has coordinates that are obvious. They're like 1 on the x and 0 on the y-axis. This is the y-axis. And it's obvious that the cosinus, as we have named this one here, the cosinus of 0 degrees is 1, which actually means that here we beautifully take the whole line, and the sinus of 0 degrees, as far as we are on the 0, is actually 0. So for 90 degrees it's pretty much the same, but not exactly, because in this case the cosinus, this one, the x-axis is obviously 0, and the y-axis, the sinus, is 1. So going to 180, cosinus is -1 and sinus is 180. Why do we have -1? Because it's here, -1, the diversion, and sinus is of course 0. And back to 270, we are straight down, and the coordinates are 0, -1, 0 on x, -1 on y. So the cosinus is of course 0, as we have said that this one is the cosinus, and the sinus is 270. The sinus is -1 here. Okay, let's make it a bit more interesting, and this time you wouldn't waste some time for me seeing me code, but let's see what I have prepared. I have prepared 3 specific angles: the 30, the 45, and the 60. Yes, these ones. Your first friends. And here things become a bit more interesting. These angles are pretty much the most common ones in the unit circle: the 30, the 45, and the 60. And with these 3 you can pretty much build almost all the angles that you would ever be questioned about. So let's take a look at them one by one. So we start with 45 degrees, this one here, and we see that as far as it's 45, it's actually sinus and cosinus are the same. You see, like here it is equal to the one here. So what does it mean? If this is the one, then the sinus is somewhere around 0.71, and the cosinus of 45 degrees is also 0.71 when we consider the whole unit circle as a 1. With the 30 degrees it's a bit more interesting. The 30 degrees we see the cosinus 0.87, but the sinus we can see it's exactly 0.5. You see, if you put like thinking about a line here, you would see that it is equal. I just think I have to start painting somehow, so you probably understand what is equal, what is exactly equal. Well, we put here 90 degrees, then this one, if we call it x, is equal to this one. So that's why the sinus of 30 degrees is 0.5. And now let's talk about the cosinus of 30 degrees. This was this one here. And the cosinus of 30 degrees is somewhere around 0.86 or 6. 0.87. When we consider that this here to be 1, we only talk about the whole radius. And now let's take a look at the 60 degrees angle. Interesting here is that the cosinus is 0.5. So what does it mean? It means that this one here is half the line. Let me make a new snipping tool. Yep, somewhere like this. So having a cosinus of 0.5 means that this one and this one, this is radius divided by 2. and this one is also radius divided by 2. So these are our friends called 45, 30 and 60. And pretty much let's move to the next one, and it would be the so-called quadrant party with 15, 165, 195 and 345. And I have also the code prepared here. It looks like this. And these are our angles: 15, 165, 195, 345, which is kind of good. We can put them a bit, no, they are okay. They are okay the way they are. I was just thinking, should I put them a bit to the left or to the right? But no. What can we say about all these four angles? They are really symmetrical. Okay. What do we mean? What do we mean by this? We mean that the cosinus of this one, of 180 minus a, is actually the same as the minus cosinus of a, and a is our here. So with other words, the cosinus of this one and this one are pretty much the same, but with a minus. I'm just going to make a quick screenshot so I can explain. So this one and this one, the cosinus of 15 degrees is actually 0.966, pretty much. I really hope I'm making sense here. So I'm going to write 0.9 then 6 cosinus. And you see that the one here actually gets the same cosinus, but just a but, and the but is that it is with a minus. So this is how it goes, and they are mirrored, so to say. And the sinus, let's say, of this one also, of 180 minus a, and 180 is here, minus 15 is 165. This is the sinus. Is actually the same as the sinus here of the sinus of 15. 165 and 15 have the same sinus because this one here is the same line. Let's see whether we can prove it somehow. MP sine and MP sine, but it's in radians, so degree to radians, and here we say fine, 15. Okay, and let's say this one is 165, and we see exactly the same number. Okay, not exactly the same because it's a floating point, but we have 258. So I hope you can see that the sinus are the same, but the cosinus should be with a difference, cos with a minus, and this one should be with a minus as well. See, minus 96. So this is what you should know from signs change, ratios stay picture. It's a nice pattern, and this is pretty much how it works. Now let's talk about sinus and cosinus that repeat themselves on every 360 degrees. And after a full rotation, you can see it here, that it doesn't matter whether we have a cosinus of 0 or of 360, it is pretty much the same. So this is called periodicity. And now let's take the new code I have prepared, looking like this. And you see from 0 to 360, from here to here, it always repeats itself pretty much. Red is cosinus. I don't see why it is not labeled. And the blue is sinus. But let's add some kind of a label, and this is how we add the label, the label just with a legend, like here. And we have the periodicity. So what is really important is to know that every 360 degrees the sinus and the cosinus are repeating themselves. Okay, now let's go we are now in the last part of the video, and we're going to talk about the golden rule, the so-called Pythagorean identity, which pretty much says that cosinus squared plus sinus squared is equal to 1, which is true. Let's take this one with 15 degrees and see this one plus sinus, and we would be squaring it. And of course it didn't take it. Probably. Okay, I'll just try to round this one. Around this one to let's think how to round this one. Okay, I know what to do. Let's do it like this. Okay, 15, and then round it. Okay, and then square it. Okay. Okay, so this one squared plus this one squared. Something like this, 97 squared plus 26 squared, really should give us 1, but let's see why it doesn't like it. Okay, float. Did we have decimal in Python? That's a good question. Decimal is not. Okay, we should import probably math. This should work. And now, what is it? Math.pow plus math.pow. Yeah, it is equal to 1. So this is the Pythagorean identity, and I even have prepared it in a nice code. So let's say here, saying that cosinus squared of this theta here is this plus sinus of the theta is equal to 1. In our case, is 0.5 squared. So this angle here should be how much? Which one has a cosinus of half? It should be somewhere around 60 degrees. Let's see. whether it is. Yes, it is a 60 degrees angle, and 0.87, which is the cosine, the sinus here, it is equal of 1. And yeah, this is the so-called Pythagorean rule for triangle, which pretty much works quite good. We can try it with something else. Let's try it with 22 degrees. I'm just curious. Yeah, with 22 degrees it also works, and no one should be like astonished. I am astonished because it sees that it is not hard-coded, which is great. We can use it with 100 degrees, and with 100 degrees it works again. As you can see, we go on the left side here on the second quadrant. The quadrants are named here first, second, then third, and then fourth. And we can do miracles. We can go with 190 degrees and it will work again. Yeah, although they are both negative, but negative times negative and negative times negative, yep, they become positive. And things work, and they work nicely. Let's try with 45 degrees. Yeah, 0.71 squared twice is 1. No questions here. And pretty much that's it. Sine and cosine are just x and y coordinates of the unit circle. I really hope that you have gathered this one from the video. Just to say it like one last time, we make here a thing. For example, saying, okay, this is the sine one. Let's put another degree, let's say put 60, so it is more visible. And we can say immediately, okay, the sine here is literally 0.87 out of the whole radius, and the cosine for 60 degrees is like 0.5 of the radius. So this is what we mean when we say x and y coordinates of the unit circles. They are predictable, symmetrical, and deeply connected. Of course, they are deeply connected. Like when you move the angle, they are both moving away. And they can be used to model wheels and anything. Pretty much that's all from VitoshAcademy and from the sines and cosines. Hope you enjoyed the video. You can play a bit with the code here. It's really interesting. You can do any type of point, and the sine and the cosine would be automatically generated. I hope you liked the video and you learned something from it. And please write something in the comments. Stay nice, stay happy, and enjoy the rest of your day. Bye bye.